Hi guys, and welcome to Chapter 2 Chemistry. Today, in today's chapter, we're going to be talking about matter and change. So what qualifies as matter? How do we describe different types of matter, mixtures, elements, compounds, and then also how can those different types of matter interact with one another? In today's chapter, we are looking at the central concept that chemistry is the central science. Remember, that means that chemistry connects to biology and it connects to physics. It bridges the gap and it really touches every kind of science that we can study. We're going to answer two questions throughout this chapter. We're going to come back to them at the end to make sure we know the answers. But the first one asks, what properties are used to describe matter? So how can we describe it? Things like shiny or flammable or corrosive. What do those terms mean and what kind of properties are those? And the second question we're going to be answering is how can matter change its form? So how does one type of matter become another type? So we're going to start looking at matter as a whole. So you maybe remember, I think this is the one thing that I remember from my childhood science, from my junior high science, is that matter is anything that has mass and takes up space. And I saw this little meme one day and I thought it was pretty funny, so I was going to share it with you guys. So it says, you take up space, you have mass, you matter. You know, it's like a little play on words, right? So you are made of matter. Everything around you is made of matter, all of it. And so matter is anything that has mass and has a volume or takes up space. So that kind of comes to this new term of mass. Okay, what is mass? Well, mass is a measure of the amount of matter. So if I were to say, like, this pen has mass, well, how much mass does it have? If I wanted to answer the question, how much mass does this have? I would weigh it, and I would get a weight, and that would tell me how much mass it has. This is kind of a confusing concept, especially when you start moving into physics or leaving, even worse, leaving Earth. So we need to just take a quick second and talk about what weight is. So weight is a force. Weird, right? Weight is a force, and the magnitude of that force is the gravity pushing on your mass. So if this is you, okay, you're standing here and you're on Earth, you have a particular amount of mass. You have a certain amount of space that you take up. You have a mass. Now you're standing on the Earth and the Earth is spinning. You're on the Earth and the Earth is spinning, and that creates this gravitational force pushing down on you. This force that's based on your mass and the spinning of the Earth, this is called your weight. So your mass always stays the same, but your weight can change, right? If you want to lose some weight, go to the moon. So if we go out here to the moon, okay, and you're going to stay the same size, you're going to be really big on the moon. So your mass stays the same, okay? Your mass is the same, but the push down is smaller. So your weight is smaller because of the force, the gravitational force is now a smaller amount, and so your weight is now a smaller amount, but your mass stays the same on Earth at the moon, okay? This is like really a physics thing, but it's kind of one of those things where I can't let you get through chemistry without knowing the difference between mass and weight. So in chemistry, all of that to say, in chemistry, we'll talk about mass and weight as if they're the same thing, but that's kind of dependent on an agreement between you and me that we're going to stay on Earth. Okay, so as long as we agree, I promise to stay on Earth for this entire semester. As long as you promise to stay on Earth for this entire semester, then mass and weight can be the same thing. If we start leaving the Earth, if we start changing gravitational forces, we're going to be in a whole big trouble because mass and weight are no longer going to correspond. But as long as we agree we're going to stay on Earth, we're going to go ahead and use mass and weight kind of interchangeably in chemistry, with the little like asterisks next to them to say that will change as you continue into further science, okay? But for now, we'll let it ride. Okay, so when we put together matter, hold on, let me get rid of this first. When we put together matter, we assemble it based on atoms. So atoms are the smallest unit of an element that maintains the properties of that element. So we have this example here of graphite. Okay, so graphite is just a type of carbon. It's a type of carbon that would typically be in your pencil. So if you take a piece of graphite, okay, we were to take that piece out, you pull it out of your pencil, of your mechanical pencil, and you snap it in half, and then you snap it in half again, and you snap it in half again, and you keep going and going and going and going until you get the tiniest piece of graphite that you ever did see, okay? And we keep cutting it and cutting it and cutting it and cutting it, and you get an electron microscope or you get some sort of crazy microscope and you keep cutting it down, 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 down. Eventually, what you would see is you get to that smallest particle of graphite, a carbon atom. And so that atom is the smallest thing that is still carbon. Can you get something that's smaller than an atom? What is something that is smaller than an atom? If you don't know, look it up. Protons, neutrons, and electrons are smaller than an atom. Those are subatomic particles. But a proton, a neutron, and an electron is not carbon. It's not nitrogen. It's not oxygen. It doesn't behave like those things. It behaves like a proton, a neutron, and an electron. A good example of how this works is if you were to think of your organ systems. Okay, so you are made of a digestive system and a respiratory system and a cardiovascular system, and you have a heart, and you have a brain, you have all of these things. They all make you you. Okay, that's you. But if I take, are there portions of you that are smaller than you? Well, sure, but if I take your digestive system just out, well, then you are no longer you, right, because you died, and the digestive system is not you. By breaking it down further than that, we've actually lost your essence. That's true of the atom too. So it has protons, neutrons, and electrons in it, and you can go even further, okay, and start looking at quanta and all this other stuff. But when you do that, you have no longer been a functional atom anymore. So it's no longer like an element. So again, for chemistry, we're really going to stop at the proton, neutron, and electron, and we're going to think of the atom as really our fundamental building block. Atoms then get stacked together, they can get rearranged, they can get recombined, they can get pulled apart in order to make every substance that you see around you. So if you want to take sugar and turn it into something else, well, then you just do a chemical reaction. You can start pulling the pieces of sugar apart. We do that in our own bodies when we digest sugar. Plants do that when they take sunlight and they excite electrons and they move it through photosynthesis and they make sugar. So we can turn one kind of chemical into another by adding or removing energy, by rearranging the bonds. But they're all with these little atoms. I like to think of them like Legos, okay? If you imagine you make a Lego car and you're playing with your little Lego car, vroom, 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 and then you're like, oh no, I want my Legos to be a plane. Well, you just take apart a couple of pieces and you reassemble them and like, now my Lego's a plane. Or you're like, no, I want my Lego to be a llama. I know it's a weird suggestion, but my daughter used to always want me to turn her Legos into llamas. So you turn your Lego into a llama and then you pull all the pieces apart, you put them back together, you've made them into something else. That's how chemistry works as well. But the pulling part and putting it back together, it's complicated. Okay, so that's what we're going to be working. So now that we've defined matter as anything that has mass and takes up space, we can say, okay, well, this is matter and this is matter, and I can say that this book has matter, and I can say that this pen and this pen have matter, and I can define them all as being matter. Well, now I have to be able to differentiate them, okay? When you were to say, like, if you were to walk into the room and go, like, I'm looking for some matter, people will be like, well, what kind of matter? Well, it's red. Okay, red, there's a property. Okay, so when you can describe matter, you are listing its properties. So we are going to spend some time in this chapter identifying actually 4 different kinds of properties that you can describe. You can describe extensive, intensive, physical, and chemical. Okay, so I'm going to write those down. So we're going to be working on these different types of properties and being able to tell the difference between them. And we're actually going to talk about each one of these kinds during today's lecture. So an extensive property, think like extensive external. This is something that depends on how much you have. Okay, so my hair color could be whatever color this is. Is this brown? We'll call it brown. Okay, it could be brown. It could be red. It could be blonde. That is an extensive property of me. It depends on my hair. I could cut it short. I could leave it long. I'm still me, right? I'm still me. That's the intensive or internal properties. So when we're talking about matter and we say, well, what's an extensive property? Well, if I were to ask you, how much does water weigh? How much does water weigh? Well, it depends, doesn't it? It depends on how much water we're talking about. If I'm talking about a glass of water or I'm talking about a swimming pool of water, they're going to weigh very different amounts. So weight or mass is an extensive property. How much space does water take up? Well, that depends. A drop of water or a cup of water or a pool of water, again, take up very different amounts of space. So those are examples of extensive properties. It depends on how much you have. An intensive property is one that doesn't depend on how much you have. It's always the same. At what temperature does water freeze? Well, it freezes at 0 degrees Celsius. That's true whether it's a glass of water or a swimming pool of water. If the water gets to 0 degrees, it will freeze. If it gets to 100 degrees Celsius, it will boil. Those are intensive properties. Boiling point, freezing point, conductivity. Does this copper wire conduct electricity? Yes, whether it's a tiny copper wire or whether it's a huge sheet of copper, it doesn't matter. They might have different weights, extensive property, but they're going to have the same conductivity, intensive property. So one of the things you're going to need to be able to identify on the exam is if I give you a property, is it intensive or is it extensive? And so one of the things that I like to think about is if it's intensive, it doesn't matter how much you have. And if it's extensive, it depends on how much you have. So an intensive property is always the same. An extensive property depends on how much you have. Okay? So we have intensive properties and extensive properties of matter.